In this question, we're taking the limit as x goes to 24 of the fifth root of x plus 8 minus 2 over 2x minus 48. Substituting in an x value of 24 leads to the indeterminate form of 0 over 0. So we're going to have to somehow rationalize that numerator. And we know how to rationalize when it's a difference of squares and a difference of cubes, but looking at that, we might wonder if we know how to rationalize given a difference of fifth powers. In fact, we do. The difference of fifth powers, and for that matter the difference of squares and the difference of cubes, is just a more general example, or excuse me, a more specific example of the difference of nth powers. The difference of nth powers is as follows. If you have a to the n minus b to the n, the first factor is a minus b, as shown with the difference of squares and difference of cubes. And the second factor is obtained by simply subtracting 1 from n and letting the first term be a to that new number. And then from there, adding subsequent terms and always subtracting 1 from the exponent on a and adding 1 to the exponent on b to the next term. So when we have a to the fifth minus b to the fifth, our first factor is a minus b. Our second factor is going to be a to the 4 plus a cubed b plus a squared b squared plus ab cubed plus b to the 4. Letting a be the fifth root of x plus 8 and b be 2, we see that in this case our second term, or excuse me, our second factor will be x plus 8 to the 4/5 plus 2x plus 8 to the 3/5 plus 4x plus 8 to the 2/5 plus 8x plus 8 to the 1/5 plus 16. So, when we expand that out, x plus 8 to the 1/5 times x plus 8 to the 4/5 equals x plus 8. Negative 2 times 16 is negative 32, so we get x plus 8 minus 32. We have 2x minus 48 in the denominator, and that can factor to 2 times x minus 24. X plus 8 minus 32 simplifies to x minus 24. And we've found our offending factor in both the numerator and the denominator. Crossing those out leaves us with this expression, 1 over 2 times that lengthy factor. Substituting in a value for 24 for x now does not lead to any problems, and we get our final answer for the limit as x goes to 24 of this expression as 1 over 160.